Hey children, welcome to Electron Chemistry Center. This is VKM, and today onwards I am going to start Neet, JEE or CET crash course. So crash course first lecture is general organic chemistry. So we will be discussing general organic chemistry for the few sessions and then followed by working session also, right? So let's move on to the topic. General organic chemistry is from class 11. So as you know, every organic reaction, how can you simply write it? Every organic reaction, simply it can be written as substrate, you can see, plus attacking reagent, and it is giving an intermediate, and then which is upon further reaction will give you finally product. So now simply in previous classes how we have studied reactants when they react with each other to form products directly. So here there are two types of reactants. One is fixed reactant. That fixed reactant, here it is substrate. Whereas another reactant, that is called variable reactant. That variable reactant is also known as attacking reagent. So this attacking reagent attacks onto the substrate, gives an intermediate which is generally highly unstable, so more reactive, and it finally gives the products. Okay, let us say if you try to understand with the help of an example here, ethylene I have taken. Ethylene is undergoing oxidation in both the examples with the help of two oxidizing agents. One is alkaline KMnO4 and another one is OSO4, osmium tetroxide. In both the reactions it is giving ethylene glycol only. If you observe it, it is giving ethylene glycol. So alkaline KMnO4 is a reagent, OSO4 is also reagent. What does it mean? This reagent, attacking reagent, is changing, but substrate is fixed. So but attacking reagent is variable reactant, that is changing, right? So attacking reagents are different, but in both the cases substrate is same. So simply what you can say, a reagent is a simple organic or inorganic compound. Any compound it can be taken, organic or inorganic compound, which is used to bring desirable changes in the substrate. So whichever the desirable changes you wanted, such desirable changes can be brought by the help of a reagent, right? So now there are how many types of reagents we have? Let's make a look on it. There are three types of reagents. One is electrophiles, another one is nucleophile, another one is free radical. These are the three types of reagents we have. So first thing is electrophile. We are going to talk about electrophiles. As you know, electro stands for electron, phile stands for love. Means these are electron loving species. These are electron deficient or electron loving species in another way. They are short of electrons. They are in need of electrons. So that's why these are said to be electron loving species. In another way, they are electron seeking species. And there are two types of electrophiles. One type is positive electrophiles and another type is negative electrophiles. These are the two types we have. One type is positive electrophiles, another one is negative electrophiles. Positive electrophiles are those electrophiles, these species can carry only positive charge. Like you can see the examples here, H plus, Br plus. Generally hydrogen carries only one electron. Plus indicates the loss of electrons. When electron is lost, right, when electron is lost and there is no electron, so electron deficient species. For suppose if the same positive charge, if it is there on the carbon, then it is said to be carbocation, like R3C plus, R2CH plus, here you can see, RCH2 plus you can see, CH3 plus also you can see, methyl carbocation another way. So any species which carries the positive charge can be considered as an electrophile. And these type of electrophiles are positive electrophiles. Next we are going to talk about neutral electrophiles. So neutral electrophiles, these species do not carry any positive charge, but they can be considered as electrophiles. So best example, BF3, boron trifluoride. Boron is having outermost 3 electrons. Each fluorine can contribute 1 unpaired electron. So 3 fluorines can contribute 3. 3 plus 3 is 6. So short of 2 electrons, and BF3 is an example of electrophile. It is an electron deficient species, but it does not carry any charge, right? So such type of electrophiles are nothing but neutral electrophiles. And if you observe the difference, a neutral electrophile attacks onto the substrate which carries the electron density, gives a negatively charged product. Whereas a positively charged electrophile, here you can see, attacks onto the substrate, it gives the product that is neutral product. It is giving the neutral product in another way. Understood the point, children, right? So now similarly you can check it. Okay, these are the two types of electrophiles, right? Hope you understand. Now let's move on to the next part, that is nucleophile. Before going to the nucleophile, I would like to mention one point here. Electrophiles are electron deficient species, so that's why these electron deficient species can act as Lewis acids. Electron seeking species, those are electron pair acceptors, right? Now nucleophiles, nucleo means nucleus, phile in the sense loving. These are nucleus loving species, means electron rich species. These are electron rich species or nucleus loving species, means electron density is very high. And there are two types of nucleophiles we have. Negative nucleophiles, one is negative nucleophiles, so charge must be negative. They should carry a negative charge here, right? Like H minus, Cn minus, X minus. If the same negative charge is present on the carbon, then it is said to be carbanion, R3C minus, right? And similarly, a negative nucleophile can attack on electron deficient species or electron deficient substrate to form a neutral molecule. Means a negative nucleophile which is attacking on the positively charged electrophile forms the neutral molecule, right? So similarly, let's move on to the next part, that is another type of nucleophile we can see, that is neutral nucleophile, right? Neutral nucleophile. Neutral nucleophile in the sense these are also rich in electrons but do not carry any negative charge. These are electrically neutral. Electron density can be indicated with the help of lone pairs. If you observe it here, RNH2, if you observe it, in that RNH2 nitrogen carries the lone pair of electrons. That you can see it here. And similarly ROR, ether, oxygen carries the lone pair of electrons. Ammonia, water, RSH, thiols, ROH, alcohols. In all of these, if you see central atom is possessing the lone pair, that means electron density is very high. So neutral nucleophiles can form a positively charged products with electrophiles that are positively charged substrates. So whenever this neutral nucleophile, if it is attacking onto the substrate, which substrate? Positively charged substrate if it attacks, and it gives a positively charged product. Okay. So and because of this high electron density, nucleophiles can behave as Lewis bases. They can behave as a Lewis bases. So there are three types of reagents, but here we are discussed about only two types, electrophiles and nucleophiles. Free radicals will be discussed under the section called reactive intermediates as a next class of course. Now we are going to talk about the breaking and formation of bonds. The breaking and formation of the bonds we are going to discuss. So what does it mean, breaking and formation of bonds? In the sense, as you know, reagent is going to attack onto the substrate, but substrate should undergo desirable changes. To undergo desirable changes, it has to break its old bonds and make new bonds. And that breaking of a covalent bond can be done by two ways. One is homolytic fission, another one is heterolytic fission. Homolytic fission is also called as homolysis. Homo means same, lysis means breaking. So the meaning is very clear. So now whenever if you consider A and B, let us say two atoms in a molecule, and A and B both are almost having same electronegativity. When both the atoms in a molecule are having same electronegativity, then it can undergo homolytic fission, right? So breaking of that type of bond leads to what type of species here? It gives free radicals. So homolysis or homolytic fission always forms two fragments, and these two fragments carries one unpaired electron or one odd electron, and those species are called as free radicals. Homolytic fission always leads to the formation of the free radicals, right? These free radicals are actually because of the odd electron, highly reactive species. And what are the favorable conditions for the homolytic fission? One is presence of radical initiators such as peroxides. High temperature is another way. There is light, you can take it as an example. non-polar medium or vapor phase, these can be taken as a favorable conditions. Under these conditions, especially in the presence of UV light, free radicals can be formed easily. High temperatures, free radicals can be formed easily. Bond breaking is easier. Presence of radical initiators such as peroxides can initiate the formation of radicals. So under these conditions also radicals can form easily, right? Now if you observe it, second type of fission what we have, that is heterolytic fission. Heterolytic fission is also called as heterolysis. So heterolysis, name indicates, hetero is different, lysis means breaking. So in which type of species you can observe the heterolytic fission in a sense? So heterolytic fission is observed in those species in which two atoms in a molecule must have different electronegativity. When they have a different electronegativity, in such cases it will undergo heterolytic fission. For suppose CX, here X is most electronegative element, then X gives the negative charge and carbon gets the positive charge. Carbon with positive charge is nothing but carbocation or carbonium ion. Now we are breaking this bond, but here C is more electronegative, then C gets negative charge. Carbon with negative charge is called carbanion, right? So heterolysis in the sense, two atoms in a molecule must have different electronegativity. When you break the bond, it will give ions. If the ion, positively charged ion, is present on the carbon, it is called carbocation or carbonium ion. If the negatively charged ion is present on the carbon, it is nothing but carbanion, right? So if you observe it here with the help of an example, CH3Cl, right? So here chlorine is more electronegative, you got negative charge, positive charge on carbon, it is called carbocation. Here carbon is more electronegative, so carbon is getting negative charge, it is called carbanion. Favorable conditions are polar solvents and another one is low temperature. These are the two favorable factors, right? So we had discussed about substrate plus attacking reagent in today's lecture. In tomorrow's lecture or in the next lecture, we will be talking about reactive intermediates as a next session. Hope you like the video. If you like the video, just click on the like button, and if you have any doubts, post it in the comments and subscribe to my channel for further updates. Until then, signing off.